moved from San Francisco to Stockholm 6 years ago. So if you are visiting this city, I hope you find this town as welcoming to you as it has been to me. I'm curious, is anyone in here, do any of you work on internet connected hardware? No? All right, well, you're gonna learn a lot about it today. A bit different from the last two talks. Today I'm going to be sharing some ideas that I have been thinking about from my work for over a decade on internet-connected hardware, from Fitbit smartwatches to Spotify Connect speakers and other types of devices, and most recently, e-bikes. I call it leaf computing, and it's what I think comes next after cloud computing. I look at it as both a complement as well as a replacement. And I think it's what is necessary to rebalance the power of technology back to empowering users first. And to explain what I mean by that, I'm going to share a few stories. So in 2015, I spent a week hiking in Banff, Canada. And it's one of the most stunning national parks that I've ever been to. Banff is filled with tall mountains, deep valleys, and really wide glaciers. And along with my usual hiking gear, I had my Fitbit fitness watch and my smartphone. And my Fitbit smartwatch, it recorded my GPS location, the steps, heart rate, all of that great data on my wrist. And at the end of the day, I wanted to view my data. Only there was a little problem. Cell coverage was basically limited to the main roads. And even then, it was super slow 3G. And it was too slow to upload all of the data from my smartwatch to Fitbit's servers. I tried, but after about 2 minutes, Fitbit would just kill off the connection. Now, I was working as a software engineer at Fitbit on its API, and I had a hunch about what the reason might be. It said our reverse proxy server timeout was set to 120 seconds. We just hadn't anticipated the possibility of a half megabyte of data taking longer than 2 minutes to upload, because that's like slower than a 56K modem. So my smartwatch and my smartphone, well, they were not so smart when I was out in the wilderness. It had some of the capabilities like collecting that data and seeing some of the data on my wrist, but I couldn't get the full experience on my phone because of intermittent internet connectivity. So that connectivity problem, that was on the client side. But problems can exist on the server side as well. And that happened to Fitbit's competitor Garmin in July 2020. A hacker gained access to Garmin's internal computer systems, and it held the company hostage for 5 days, demanding $10 million. Now, we don't know if Garmin paid that ransom, but for 2 days, it was just completely offline. And many of Garmin's smartwatches, they just didn't sync for 2 days. But server outages, they're not just caused by hackers. If you've ever used Amazon Web Services in the US East 1 region, you know this. So AWS, it's the most popular cloud infrastructure provider in the world. It has about 1/3 of the market share. And the US East 1 region, it's the most popular data center. It's the default region for a lot of AWS services, and it's typically the first region that gets all the cool new features. So this means that a significant portion of what you do online every day probably touches AWS's data centers. So what happens when it goes down? Well, we don't have to imagine because we get a reminder every few years. Most recently, in December 2021, AWS US East 1 region, it went down 3 separate times, and the worst incident was for about 7 hours. So popular websites like IMDb, Riot Games, Slack, Asana, they were just down. But websites and apps going down that depend on the web, that's not really an unexpected thing in such an outage. More interesting to me in this outage was that floors went unvacuumed during this time because Roomba robotic vacuum cleaners stopped working. And doors went unanswered during this time because Amazon Ring doorbells stopped working. And some people, they were left in the dark because their smart lights couldn't turn on and off. But eventually things did start working again. So I mentioned hackers taking servers offline and cloud providers accidentally taking themselves offline. But another way that servers can go offline is when you stop paying for them, because your company goes out of business. So just last year, smart home company Inseon abruptly ceased business operations one weekend. Its customers' automations for lights, appliances, door locks, and such, they just stopped working without warning. Emails to customer support went unanswered, the CEO scrubbed his LinkedIn profile, The company just vanished, and millions of dollars in smart home electronics became e-waste. So the point of the story is that so many of the physical devices that we now own require not just electricity, but also constant internet connection. They might be right beside you physically, but they're a world apart because they can't connect to a server on another continent. Okay, final set of stories. There's this internet meme. There is no cloud, it's just someone else's computer. And the point of this meme is not to disparage what I think is a genuine innovation of seemingly boundless computational capacity available instantly with an API and a credit card. The point of this meme is to remind people that when you put data into the cloud, you are entrusting other people to take care of it. And unfortunately, some of the companies and the people who work at those companies have not always done the best job of that. In 2021, security camera company Verkada had thousands of customers, from big corporations like Tesla to hospitals, airports, and even Sandy Hook Elementary School. Now, its products not only provide the video surveillance, but also facial recognition of the people in the video. So this data was extremely sensitive. And one day, Verkada's customers got an email informing them that a hacker had gotten access to a so-called superadmin employee account. And this account allowed hackers to see all of the live video feeds and archive video of Verkada's customers. This was a huge breach. Now, the most interesting admission by Verkada to me was not that a security breach had occurred. Those happen. But that there was an employee account with this level of access to customers' data in the first place that could have been hacked. Just a year earlier, a whistleblower went public with accusations that Verkada employees were abusing the level of access that they had to customer data. They alleged that some employees were taking screenshots of women in the security feeds and then sharing them internally. Now, the company, of course, denied this, but hackers confirmed that this capability still very much existed just a year later. Now, Amazon Ring, it truly wins the worst prize. It not only has extensive allegations of broad employee abuse of customer data and being hacked multiple times, but it also has admitted to giving police customer data without user consent, and sometimes without a warrant. So in one case, Ring not only provided the data that was requested by a court, but also additional video inside of a customer's home that was completely unrelated to that investigation that then became public record. So people just wanted a way to easily unlock their door, and they accidentally created a police surveillance state. Now, this goes beyond invading the privacy of individuals to potentially harming all of society. And this is the present state of things. I've shared stories about internet-connected devices, internet-connected products not working well when that connection is bad, not working at all when the servers go down, and then actively working against their users when trust is misplaced. The central theme to all of these stories is the cloud architecture. So does it have to be like this? Are we stuck with the internet of shit? Well, I want to look at that smartwatch example and try to figure out how we could achieve the same user experience in a way that works offline, doesn't rely on trusting someone else to protect your data, and doesn't become e-waste if the servers go away. So the typical present-day architecture for smart products looks something like this. A smartwatch connects to an app on the phone via Bluetooth to relay data from the watch to the server, because the watch itself doesn't have a constant connection to the internet. Wi-Fi is just not always available, and cell radios, they're expensive and they drain the battery, the tiny battery. So the server then does a bunch of processing of that watch data. It sends it back to the phone, which then loads the state back into the watch. And then when you go use the app makes a bunch of API requests to the server to retrieve that watch data, but reformat it in a way that's easier for an app developer to use. So for example, the number of steps that I take, that could be represented as a daily summary, a minute level time series, or maybe as like progress against a daily step goal from a specific workout. Another example of processing is raw GPS data. If you've ever looked at GPS data, it looks like a scatter plot of points with varying levels of calculated accuracy. And it's often just not usable unless you do some smoothing, which requires doing some recalculating of distances to more closely match reality. So the server is actually doing some stuff. So how could we make this work offline? Could we just get rid of the server? And what would it take to do that? Well, this would mean moving the logic that exists on that server into the client, into the smartphone app. And in this case, it's actually a very reasonable thing to do. Most people's smartphones are now more powerful than the laptops that they use, often with more RAM and storage space. And there's no significant performance benefit of using a powerful server to do these type of computations. So getting rid of the server in this case would not only shift the computation expense to the phone, but it also eliminates the data storage cost and the security responsibility of the provider. The data would stay on the phone, and then people can use the encrypted backup features of their phone to keep their data safe. So this saves businesses money and is more secure for the customer. It's a double win. And what I love about this proposal is that it's not unrealistic. This is, in fact, exactly the architecture that Apple chose when it introduced its own smartwatch, the Apple Watch, which I use today. So the Apple Watch's cloudless architecture is inherently more secure because the data stays on a device within your control. It's more resilient because it's not dependent on network connectivity to function. And it's more ecological because if Apple stops making the watch tomorrow, it keeps on ticking. Now, the problem is that other smartwatch makers have not chosen to imitate this cloudless architecture, and the problem is not limited to smartwatches. So most smart home products today still unnecessarily rely on a cloud architecture, some even downgrading their capabilities after purchase, like Hue lights. And many smart e-bikes work exactly like Fitbit's cloud architecture. If you have any friends who have a VanMoof e-bike owner, ask them how they're feeling right now. This just happened recently. So companies and developers, they just seem fixated on cloud services. So why is that? Well, the cloud architecture is pretty much the default choice today. It's established, it's easy to get consensus to build. There's a ton of tooling to build products in this way. It's great for business because companies can justify another subscription from you from a recognizable ongoing operational cost, and then they have the recurring revenue. And marketers love it because they can mine customer data that's stored in their cloud for insights without having to ask permission. So to change this, I think we need to name an alternative to the cloud architecture and to describe the characteristics to help people understand the benefits. We need to describe it by what it is, just not by what it is not. So today I'm going to be talking about the Leaf computing architecture. The Leaf architecture defines software that is locally executed, which means that the business logic happens on a device within the user's control, and the user data is stored without having to trust another party. Leaf software is autonomous, which means it has as little reliance as is possible and practical on external sources for capabilities. And Leaf software is federated, which just means that it prioritizes interoperability of capabilities and data portability across multiple providers. So let's go deeper into each of these aspects, starting with local execution. Local execution is about two things. Where does the code run, and where does the data get stored? So this might sound like another similar idea called offline first if you do any front-end web development. Alex Fierke wrote about apps being offline first in 2013. And he advocated for moving the logic to the client side to do the work offline, and then using client databases that were sync friendly so that they could share and receive an updated state with the server when that connectivity was restored. And this reduced the server to only doing things that the server is necessary to do, like mirroring data for backups or for facilitating multi-user or real-time collaboration. In the case of client apps, local execution has a lot to be inspired from offline first techniques. But local execution is more about who controls the device where the logic is happening and where the data storage happens. So it's also possible to think about local execution happening on a server that is intended to be always online, but is also under control of the user. Now, I don't know if you remember before the cloud, but before software as a service became the norm, software companies released their software to IT departments that they would typically install on their own local servers, usually somewhere in the physical office where people actually worked. Well, today, the best-in-class software, it's just not made available in that way, and even if it were, there's not really an easy and reliable way for organizations to administer their own servers. So we have some self-hostable open source alternatives to Slack, Jira, Confluence, those sort of things, but they just aren't as capability and as user-friendly yet. And they also require someone who knows Kubernetes or Linux to keep them running. But dream with me for a moment. Like, why can't we have an Office server with apps that are as easy to install and update as they are on our smartphones? Like, I predict that someone will eventually make the server equivalent of an iPhone and App Store, and then when that happens, local execution will be possible for both offline first and online always apps. By the way, Nextcloud is one company that's trying to realize this dream. I don't work for them in any way, but it still has a long way to go, and I'm cheering them on. The next aspect is that Leaf software is autonomous. So local execution and being autonomous, they go together quite closely. Software is autonomous when dependencies on external services are reduced to as much as is necessary. It does not mean complete isolation. I like to think of this as cloud-assisted software, because the power of the web is in part our ability to build and share the unique capabilities over a network, and we don't want to lose that. But autonomous software is just further empowered by those external dependencies, not powerless when those dependencies are unavailable. And I think that's a really important distinction. And lastly, Leaf computing utilizes federation. So federation is just a fancy word for playing nicely together. It's a spirit of cooperation between products. And in software, this means sharing data formats and protocols. Many products can interoperate simply by reading and writing data in an agreed upon format. But other times we do need to define protocols or APIs so that products know how to communicate with each other, because maybe it's not data that's being exchanged, but it's a capability that's being shared. So to recap, Leaf computing describes software with an architecture that's locally executed, autonomous, and federated. It's appropriate for software where the user is authoritative, and it is not appropriate for situations where the user must ask for permission to do things. So it would be inappropriate to use for an online store, because the store has to manage its inventory and take payments and things like that. So let's try to put this into practice by redesigning a smart air purifier from Miele, which I brought in today. This product actually exists, as you can see, but it uses a common cloud architecture. And I love it, but I want to redesign it to get rid of the cloud and to use the Leaf architecture. So this smart home air purifier, it automatically senses the indoor air quality and adjusts its speed accordingly. And it also has the ability to schedule features like be a white noise generator when I'm trying to sleep from its mobile app. It's super smart, so I excitedly buy it, or 3 of them. So I take it out of the box and I plug it in, and I want to connect it to my home network. And to do that, I push the Wi-Fi protected setup, or WPS button on my router, and it just magically joins my network. So WPS, it eliminates the need of a complicated pairing process or remembering your Wi-Fi passwords. But what's smart about this? Well, a smart air purifier is basically just a dumb air purifier, but this one features a web server that's also serving a progressive web app and some APIs. It can use Zero Configuration Network, or ZeroConf, ample bonjour, other names, to make itself easily discoverable on my home network. And so the screen on this air filter tells me to go to airfilter.local on my phone's browser, and when I do that, I see a web app that shows me the history of the air quality, and it also has that setting for scheduling the white noise mode for when I'm sleeping, and that's neat. All of this configuration data in the historical air data is going to be stored on the air purifier itself. All right, but what if I go on vacation and I want to be able to control it when I'm not on my local network? Let's say I don't want it running because electricity gets expensive. Well, the challenge for these sort of smart home devices is that I can't connect to a device inside of my home from outside of my home easily because of network address translation, and well, opening ports on your router is just complicated. So the typical way that smart home device manufacturers deal with this is that they just move all of that control logic and data back up to the cloud. But we want to keep this air purifier as autonomous as possible. Well, fortunately, we have a standard called WebRTC that allows for peer-to-peer data connections, and it's what's used in most video chat apps today. I'm not going to go into the details of the sequence diagram on how it works, but the important details is that it allows 2 parties on separate private networks to establish a peer-to-peer connection using only a cloud assist to get started. So Miele could host a website for this cloud assist, and then my smart air purifier connects to that website, shows me a different link on the screen that I can go to on my phone. And then when I connect to this website, the website's going to facilitate a peer-to-peer connection between my phone and the smart air purifier using WebRTC. then the air purifier can go about serving its progressive web app and all of the data to my phone just like it would as if I were on my home network. The cloud server does nothing else. The app on my phone and the air filter are talking directly to each other once that they get initially connected. So I'm running out of time, but if you're curious to learn more about how smart products can use Leaf computing to do things like push notifications, local machine learning, external web APIs in an additive manner, and other privacy-preserving telemetry, and all sorts of things that you need in a smart home product, check out leafcomputing.net. By creating software that is locally executed, autonomous, and federated, we get products that are more secure, more resilient, and not at risk of becoming e-waste prematurely. The Leaf computing architecture, it benefits the user while reducing risk, liability, and operational costs for the manufacturer. And what's great for the environment is also great for the wallet because you aren't paying for as many server resources. So I hope you join me in creating technology products with these ideas. I think the future will be a lot less bright and sunny when it's a lot less cloudy. Thank you so much.